Hello all. Thank you to being here to watch the video. Today I am excited to present to you MilkPro Data Pipeline Project. This project aims to build a scalable and real-time data pipeline for milk processing and analysis. Through this presentation, I share the insights of project with you all. Let's take a look at overall project overview. So in this project, different tools are used like a Kafka, PySpark, HDFS, and Hive. Using a Kafka, data is injected into the system. This data it is transformed by using PySpark Dataframe API. During this transformation, some of the business logic is created like milk categorization and data segregation. After business logic, it involves some process data we got. This process data it is now storing in the HDFS, and for the data analysis we use the Hive. A Milk Pro data pipeline holds several critical business objectives which include improve milk quality control and assurance, optimize milk production process, and enhance data driven decision making across the organization. We will achieve this by categorizing milk into a different types and based on specific parameters. This categorization will help us to understand the properties of different milk types and identify regional variation in the milk quality. Additionally, the fourth objective of this project ensuring the data quality through error handling. So here we have implemented a robust error handling mechanism to detect and handle bad data process. To understand our data better, let's deep dive into a key data parameters we are dealing with this project. So there are more than six parameters. In these six parameters, four different parameters are very crucial, like a fat percentage, protein percentage, lactose percentage, and temperature of the milk. These are the four parameters are very important. During the milk procurement, the timestamp and the area it is created at the data center, milk procurement centers. At the same time, some unique farm ID as well as batch ID it is created. So business logic. So in this project, some business logic is also been implemented. These are the four business logic it is implemented in this project. Like first number, location based data segregation, error handling, data storage in HDFS, and a Hive analysis. Last one it is alert email generation. So this four business logic is developed. It is implemented in the in this project. So before moving to this workflow diagram, we first see some code. So right now, the server gets stopped. It is running once again. We're running the server. Right now, we are using the IT Versity server, and using this IT Versity server here, it is the cluster. I also use the cluster of that the same company. So here it is a consumer code for this project, producer code for this project, as well as we required a terminal. So in the terminal, we first verify if our any old data it is there or not in HDFS. Okay, so in the HDFS, it is showing some of the old data also. Okay, so we have to remove this all the files before running the code. So all the paraquat files are removing using Linux commands. The last file it is there. Is deleted. So we have to once again we checked all the files are deleted from the HDFS or not. Yes. So right now in the HDFS there is a no any paraquat files of this project. So HDFS it is very clean now. So for the alert message, I use this mail. So right now it is no any mail from this project. So this is a consumer code I write over here. I will explain afterwards, as well as this is the producer code. So running this producer as well as consumer code right now, because it takes some two, two, 2 to 3 minutes to generate the data. So right now I'm running this Spark session in the producer code as well as Spark session in the consumer code also. So producer in the producer Spark session it is created as well as in the consumer also. So initially I run the producer code, okay, and after right now I'm running the consumer code also. In the below of consumer code there is a no any data, no any result it is there. After 1 or 2 minutes, here the data it is coming of the data frame we have to see. So meanwhile we move to our presentation once again. Let's walk through the data flow architecture of a MilkPro Data Pipeline Project. So we ingest data from various source like a milk center data entries, sensor data from the milk processing unit, like, and this. So right now to replicate this data, we are using a faker library to generate the synthetic data. That now this data it is undergo a transformation and processing using a PySpark data frame, where we apply our business logic for milk categorization and data segregation. This process data is then stored into a HDFS, and we integrate it with Hive to perform an in-depth data analysis. Before move forward, let's take a moment to understand how the Kafka play a crucial role in our data pipeline. Kafka acts as a backbone for the data transportation, allowing seamless communication between consumer and producer. So in the Kafka producer, using a sensor, web application, or database basis, some data it is ingested into the system, and the Kafka consumer it is decoding all the data which is ingested by the Kafka producer, and it is move in a messaging format, or it will store in some of the database. The same logic we applied in the our project or our data pipeline. The producer code it is there and consumers so it is there. The project having producer where the some of the milk properties data it is generated. This same data it is sent by using Kafka producer to the Kafka consumer, This data it is received by the consumer. Data now it is processed. This processed data it is now stored in the Spark successfully. During this process, if any error it is found, then the error handling mechanism it is also been created. So the business, one of the business logic, it is the location based data segregation. So for this implementing business logic, we create a four different location using a procurement area like a Karad, Navarasta, Patan, and Koina. And using this four different area, data it is segregated. Last business logic, it is a data handling and data quality or alert email system. So initially during the data transformation, data validation and cleansing techniques it is used, and during this the bad, if any bad data it is created, then this bad data it is stored in a different table, and this bad data table it is created, then alert system will be start, and it will send a mail to the appropriate person. At last, the data storage and the Hive integration. So HDFS efficiently store the process data, and additionally can integrate HDFS with Hive for data analysis. In the Hive, we implement milk categorization using a SQL queries. This process segment milk into a various types. In this way, we do the milk categorization. We do four different types of milk categorization, like a skim milk, double tone milk, standardized milk, and full cream milk. All the four milk categorization it is based on fat percentage, which is a zero point 0.5 to zero point 0.5. Below the 0.5 percentage it is there in the milk, then it is a skim milk. Then if the fat percentage it is in between zero point 0.6 to 2.9, then it is double tone. Fat percentage it is 3 to 5.9. The standardized milk, then full cream milk it is a 6 to 9 percentage. So right now we move once again to our code review. Okay, so this is the consumer. Okay, so here it is some data it is created. This data frame is showing a Navarasta data frame, pattern, then Koina and Karar. These are the four data tables or data frame according to area, and some of the bad data it is also we get. Okay, and if the bad data it is come, then also a email it is sent successfully. So we checked email we got or not in the mail. So see here the bad data alert it is coming. Dear manager, we detected the bad data in milk processing unit. You required to take necessary action regarding this. So we checked how the code it is written. So initially we go from producer. In the producer, we one of the business logic it is there for location based data segregation. For that we created four different areas. Okay, so using these four different areas, we write the farm IDs. These are the some of the data parameters like a data timestamp, fat percentage, protein percentage, lactose percentage, and temperature. Then we know all key the procurement it is done in the morning as well as evening. So for the morning it is period it is M and E. So according to morning and evening, batch ID will be created differently, and this all the parameters it is put in one message. Okay, and this message it is sent using a producer. Okay, then this code it is written for flushing the old data. This inside for loop created 1,000 records of all the parameters, and this inside loop it is sleep for the 60 seconds. 60 seconds. And if we required this thousand data in some of the interval of time, then we have to only change the outer loop or how many times we required this data. If we require 10 times, then we have to only change outer loop to 10 times, and how much interval of time duration, then we have to change this duration. Okay, according to that, we get the data from the Kafka producer, the code review of a Kafka producer. Then we move towards a Kafka consumer code. So initially, this the message comes from the Kafka producer. It is here. It is we have to decode it. Okay, and after decoding, we have to separate this message using a comma, and all the values we have to store in different parameters. Then these different parameters, it is now we required some data frame, and we required also the schema. So right now using this code, a schema it is created according to the data type. Also each tables required some different data types. Data frame, frame, it is created over here. So the business also, one of the business logic it is there key, it required a more quality in the milk processing optimization. And if any bad parameters it is created, then it will be stored in a different table. So for to implement this business logic, I created some of the condition, like if the temperature it is less than 63 or more than 75, it will be segregated according to the area. And if it is there, if the data it is created below the 63 temperature or more than 75 temperature, then it will be stored in a bad data. Okay, this if the bad data it is coming, the it will also store in a different uh, table. So all the data frames we have to store, we require to store in a HDFS in a paraquat file. So using this code, we store all the data in the HDFS using paraquat file. Also, I created the override mode also. If by mistakenly some of the times the data it is created, and if the old data, we have to override it. So at the last, we implement the fourth number of business logic, which is a alert system, email alert system. For this, I write this code, and here it is a try catch method also to handle the error system. If the bad data it is created, then this message is also showing the email sent for the bad data alert. Okay, if not, then this message. Okay, so at the last of this execution of this code, the bad data, we get some of the bad data. That's why email system it is created. Okay, and email also sent for the bad data. So email system it is working very fine. So email it is go for the appropriate email ID, because the in the email address here it is email receiver email, it is this yogesh.yp999. Same here it is yogesh is created automatically. So now the last point in the business logic we see the first number, it is a localized data segregation. Here it is localized data segregation is done using a batch ID. Okay, then the HDFS, in all the process data it is stored in the HDFS. So here it is. This is the code for storing the all data is in the HDFS. Then at the third point, it is the email alert it is there. If the bad data it is generated, so email alert it is there. Last one, it is a data analysis in the Hive. We will see this in the cluster. So now the code is run and some files will store in the HDFS. So first see if the file it is stored in the HDFS or not. Otherwise, copy this code and the terminal. uh, Okay. So see here it is. Data according to area as well as bad data frame. It is also stored in HDFS in the paraquet file format. So we go to the Hive shell. In the Hive shell, we first uh, set our database and see the tables. So I use this database and database like test db is there and show tables. I entered it. So here it is. There are data. This table it is already created. So I have to override it. Drop this table. This table drop query. But before moving forward, we have to check table it is there on. Right now, Karad underscore data table it is not there. So we have to create an external table using a paraquet file. These are the table columns like a milk ID, batch ID, farm ID, area, milk timestamp, fat percentage, protein percentage, lactose, as well as temperature, and this all data we have to store. We have query. Okay. So external table it is created in the Hive. Then and the last we required to implement the milk categorization business logic using this query. But like copy this query and put it in the Hive enter. So it will give us the milk according to the categorization we use this category. Why to now? Okay. So see the categorization it is done. See, all the data according to the parameters it is divided in milk categorization. We use different queries, data analysis in the Hive. So the milk, so this Milk Pro Data Pipeline Project holds significant potential for enhancing the milk processing and analysis. With the scalable data engineering technique, we aim to the milk quality control, optimize production process, and enable the data driven decision making process. I'm confident I am confident that this data pipeline project will provide a valuable insight and contribute to its growth and success. Thank you all for your time and attention. Thank you.